Hey, this lesson today is about solving for the equivalent resistance of complex circuits. So one thing I can tell you, it is critically important that you draw each of the circuits each time as we simplify the circuit that you see on the board down to just one resistor. So what we're trying to do is figure out from the battery's point of view, what is the overall resistance attached to it? It doesn't know how many different resistors there are. We want to know if there was just one resistor attached, how much resistance would it be? But as you will see in the coming days, as we start to work backwards to solve how much current and potential difference is there for each of these different resistors, you have to keep track of every single resistor. This is really important. Think of it kind of like a family tree. These little resistors put together a little baby resistor, and then there's new baby resistors. And we don't want to forget great grandma, right? We got to remember everybody in the tree, and you will see later why this is so important. So it is absolutely important and required that you redraw the circuit each time. It's also equally important to hear what you can do as what you can't do. If we were here together today, I'd ask for some volunteers, but I'm going to try to give you some common answers that I get from students and try to explain what you can and can't do. Right? Basically, what we're looking for is a simple series or a simple parallel circuit. You know it's series if all of the current from one goes to the next, goes to the next. So for instance, a common thing that students will say is that these three resistors are in series. And it kind of looks like that, except all of the current that goes through here doesn't have to go through this resistor. It could split and go this way. So only some of this current makes it through the 340. Some of it loops around through those other loops. So that is not a simple series, so we cannot do that. Again, hearing what you can do is just as important as what you can't do. Some students will also say that these three make a parallel because it kind of looks like that because you see that parallel structure. However, in a parallel, that means the current either goes through this one or this one or this one. Well, there's more going on here because the current that goes through this also goes through here, but the current that goes through the 340, it never makes it through that 249. So that is not a simple parallel circuit. So really the only one thing that you can do at this point is when the current gets here, once it's decided to go down that branch of the path, it has to go through the 103, the 141, and the 185. All three of those are in series because once the current makes it to here, it has to go through all three. Now you might be asking, well, what about the 249? Because it has to then go through that. The problem with the 249 is that current also comes from the 458. So the current is coming from two different sources to get to that 249. So we're not quite there yet. So the only thing we can do right now is take these three resistors and put them into a simple series. So all we have to do for series is the easy one. We just add those three numbers together. So I'm not going to take my calculator and show you that. What I am going to do is redraw the circuit, and it is required that you redraw this every single time as we work towards simplifying. So what this looks like now, and it doesn't have to be super neat, but you have that one there, this one here. You've got this one here, this one here. And what we have done is we've taken those three and reduced them down to a single resistor. Now it doesn't matter if this resistor that we just combined goes here, here, or here, but somewhere along this branch on the right-hand side. So let me just fill in the numbers. This we haven't done anything to. 147, 369, 249. This is still 340. This is still 458. But what I did do is combine these three on the left-hand side that are in green. And when those came together and I added them, I got 429. Okay, now we have to again look for any circuits that we can put together. So again, you might be thinking, well, I see a parallel, 340, 458, 429. So some students would think all three of those are in parallel. But once again, we can't quite do that because the current that comes from the 458 and the 429, it's directed through this 249. But the current going through the 340 never makes it through that 249. So we cannot put all three of those in parallel. But what I can do right now is just put these two in parallel. Because when the current gets to this point, it's either going to go this way or this way, just through those two circuits. So what I'm going to do on my calculator is it is a parallel circuit, so you don't just add them together. We're going to do 1 over 458 plus 1 over 429. And then remember, you have to take the reciprocal of that. So 1 divided by that, use that full decimal so you're not rounding. And we're just going to call it 221. Good enough. So I'm going to go ahead and redraw my circuit again. I know this may feel a little annoying, but it is absolutely critical, or you will not be able to do what we're doing from here. Right? Today is just a step in learning something further later on. Great. So I just took these two and combined them together, and the answer I just got was about 221. Now, I'm looking for another simple connection I could do. And again, I cannot do parallel with these two, the 340 and the 221. I can't do parallel with that because of the 249. However, the current that gets here, once it gets into this part of the circuit, it has to go through the 221 and it has to go through the 249. So those are a simple series. It's locked in, it's got to go through both of those. Now, some of you may be thinking, what about the 147 and the 369? Doesn't the current have to go through those also? Yes, it does, but the thing is, the amount of current going through the 147 is not the same as the 221, because when the current gets to this junction, some's going to go through the 340. So since all of the current coming from the 147 doesn't make it to the 221, I can't put those in series. Same thing with the 369. The current that gets through this circuit came not only from this branch over here, but also this branch in the middle. So that has a different amount of current flowing than just this right-hand branch. So all I can do right now is put those two into series. Again, series is the simple one. You're just going to add those together. So what I've got now, I still have that 147. I still have the 369 at the bottom. I still have the 340 over here. But what I've done is combine those two resistors in series. I just added them together. It makes about 470. Now, please note, it doesn't matter if you put that resistor here or here or here. It really wouldn't make any difference. I just decided to stick it on that side. As long as it's in this branch, it really doesn't matter where in the branch it goes. Great. Now, next thing, we're looking for another combination. Once again, you cannot do a series with this, this, and this, because all the current going through the 147 doesn't all make it to the 340, because it splits. So I can't do series with these three right here, even though it kind of looks like it, because there's this parallel connection in the middle. So in fact, that's what I need to do first. I need to do this parallel connection right here. So I'm going to grab my calculator, and I'm going to do 1 over 340 plus 1 over 470, and then I'm going to do 1 over that. And I'm going to end up with a number less than either 340 or 470, because in parallel, when you put the resistances together, it always gets smaller. So I'm just going to redraw it over here, 147. Again, I just did these two in parallel, and I got an answer of about 197. And now finally, I see that I have just a simple series connection left. So what I'm going to do is just put those together, and what I have now is simply my battery. So there's my battery, and I've got one resistor left, and that means that this is the equivalent resistance of the circuit, which would be 713 ohms. And again, the way that I got that answer is because it's series, I literally just added those three numbers together. Okay, that is probably, in fact, that is the most complex circuit we are going to deal with today. So if you could follow that, you are well on your way. I'm going to do one more example with you and show you how there are times where we can do a couple things at once. to make this go a little bit faster. In this case, we really couldn't do this, but this one's slightly different. So in this case, again, I'm trying to get this down to just one resistor. And as long as I'm not taking a new resistor and combining it with another resistor, I can go ahead and do multiple things at once. So I want you to think for a second to yourself, what connections could I do right now? And I would say there are three things that I could do right now that are separate little either series or parallels that wouldn't require me to put multiple answers together. Okay. So one thing that I can do is all the current that goes through 435 has to go through 473. Now at that point, it's going to split all over the place, so I cannot do any other series, but I can go ahead and take these two and put them in series. So I'm just putting an S there to mark that that's series. Now, over here on the right-hand side, you kind of see a parallel structure, but because these two are together in a branch, once the current heads down this branch, it has to go through both of these. So that is another series connection. I cannot do parallel with these three on the right-hand side yet because there's two in one branch. I need just one in a branch in order to do parallel. And in fact, as I look down here, that's exactly what happens. The current is either going to go this way, or this way. So it is going to pick exactly one of those three resistors. It's not going to go through all three. It's not going to go through two of them. It's going to go through either the 612, the 586, or the 530. Just one of those. So this is a parallel circuit. So since none of those involve each other, I can go ahead and do all three of those at the same time. So I'm just going to go ahead and redraw this over here. I'm putting these two together right now, the R1 and R2. And since they're in series, I'm just adding them together. So that's 908 ohms. I'm going to keep that 492 that's right here. Now what I'm doing for this one is I'm adding these two series connections together. So I'm literally just adding those numbers. That would be 395. So I'm just trying to color code a little bit where that came from. The 439 is still the same thing. And then finally, I'm doing this parallel connection. So I'm going to do 1 over 530 plus 1 over 586 plus 1 over 612. And then once I get that answer, I'm going to do 1 divided by that number. Okay, so you should know how to do a parallel connection by now. So when I do that parallel connection, I get 191. Okay, so now what I'm going to do, we're almost done. I have basically 2 more steps. What I see now is a parallel circuit on the right-hand side. The current has a choice. It's either going to go this way, or this way, or this way. It's going to go through one of those 3 resistors. So I'm going to go ahead and do a parallel connection with those 3. So once again, I'm doing 1 over plus 1 over plus 1 over, and then take 1 over that answer. When I do that, I get a number much smaller. It's only 146 ohms. So where I'm at now, I still got the 908. This is, as I said, I believe 146. This is 191 still. And finally, what you can see is I just have a series connection. So I'm just going to add those 3 numbers together, and my equivalent resistance works out to be 1,245 ohms. Okay? And again, what we're going to be doing from here is we're going to be taking that value and finding the current through the circuit and working our way back up, and you are going to be able to tell me the voltage or potential difference and the current going through any part of this circuit. And that's what we'll be working on starting tomorrow. Great. You see one more circuit on your paper. I am going to allow you to finish this one yourself, so this is part of your assignment, is to finish this one off. I will tell you right now, just from the get-go, I see 1, 2, 3, 4, 5 things that I can combine first, like 5 different pieces of that circuit that I can combine in order to start reducing this down. And I will tell you what the final answer is. You should get a final resistance of about 165 ohms. If your rounding's a little bit different, that's